Every bridge begins as a vision, a bold idea drawn on paper, born from a single question: can we cross what once seemed impossible? From that question comes a masterpiece, a structure that defies nature, unites communities, and becomes a symbol of human strength. What you're about to discover is the fascinating process of bridge design and construction, a world where imagination meets mathematics and steel becomes the language of connection. Before a single beam is forged or a foundation is laid, the bridge is created in the mind. Engineers and architects spend years transforming dreams into detailed blueprints. They study the terrain, the water depths, the soil beneath, and the forces above. Every calculation must be perfect because one mistake here could cost billions or lives. It all begins with design. Using advanced 3D modeling and simulation software, engineers test the bridge long before it's built. They analyze load distribution, wind pressure, and earthquake resistance, running virtual models through thousands of scenarios. If a storm hits, how will it sway? If heavy trucks cross for decades, how will it flex? Every answer shapes the next decision. Bridges aren't just about strength, they're about balance. A good design must carry weight while bending gracefully with the wind. That's why engineers study aerodynamics, allowing air to flow through and around the structure without resistance. The iconic curves and cables you see aren't just for beauty, they're the reason bridges can stand through storms that would tear others apart. Once the design is proven, the factory phase begins. Giant workshops roar to life as molten steel is poured, pressed, and cut into enormous beams. Each piece is built with millimeter precision, marked, and tested for strength. A single segment can weigh over 100 tons, yet it must fit perfectly with the next one when assembled miles away. When the materials are ready, they begin their journey to the construction site. It's a massive operation that blends timing, coordination, and precision. Before anything rises, the most difficult part comes first: the foundation. Beneath rivers, lakes, and oceans, engineers build cofferdams to hold back the water. Inside those barriers, workers pour reinforced concrete deep into the ground, forming pillars that anchor the entire bridge to bedrock. Some bridge foundations extend more than 30 meters below the surface, strong enough to carry the weight of a city. Once the piers are set, the structure begins to climb skyward. Colossal cranes lift massive beams into place, each one positioned with breathtaking precision. Every bolt tightened, every weld completed. It's a delicate dance between human skill and mechanical power. Then comes the heart of it all: the cables. Thousands of ultra-strong steel wires are bundled to create cables that can support more than 20,000 tons. These cables stretch from tower to tower, transforming tension into balance and turning gravity itself into stability. As the deck sections connect, the bridge takes its elegant shape. From afar, it looks effortless, yet every joint, every beam, carries the weight of years of design. Engineers monitor every movement as the halves inch closer together, until finally, the last segment locks into place. When that happens, the bridge stands as one, a living monument of human achievement. Before it opens to the world, it must prove its strength. Heavy trucks roll across the surface as sensors record vibration, tension, and movement. Each test confirms what the engineers calculated years earlier: the bridge is strong, stable, and ready to serve. Modern bridges are smarter than ever before. Hidden inside their steel and concrete are thousands of sensors that never sleep. They measure vibration, temperature, and microfractures, sending real-time data to control centers where engineers monitor every heartbeat. These smart systems detect changes long before damage appears, allowing maintenance teams to act early and save the structure. Because building a bridge isn't just about creation, it's about giving it life. These structures listen, react, and adapt to the world around them. And even after construction, the work never ends. Teams wash, repaint, and reinforce the bridge, ensuring it stands strong for generations. Longevity doesn't come from materials alone. It comes from care, from people who dedicate their lives to protecting these colossal creations. Every bridge tells a story of creativity, risk, and relentless human spirit. From the Golden Gate to the Millau Viaduct, from the Danyang Kunshan Grand Bridge to the Risund Link, each is a masterpiece of will and wisdom. They are more than structures, they are lifelines. They connect nations, economies, and hearts, turning isolation into unity and dreams into destiny. The next time you cross a bridge, remember what lies beneath the surface: the sleepless nights, the careful calculations, the courage to build the impossible. Because these are not just bridges, they are proof that nothing is too far, too deep, or too impossible when humans decide to build. And this is the amazing process of bridge design and construction. Thank you for watching, and don't forget to subscribe for more amazing journeys into the world of engineering.